Hi guys, I welcome you to today's Pi and AI Suisse session. We have a fantastic speaker today. We have Gérard Dupont joining us, who was an Airbus specialist and researcher, talking about a subject of high interest, how to build a question and answer system for flight crews. Unfortunately, we did not record at the beginning of the session, but that doesn't matter, because the most important part, the discussions, your fantastic questions have been recorded. So enjoy the time and listen to one with highly expertise in that area and subject. Thanks again, and hope you enjoy it.
Which is still decreasing because it's ordered by this score. But if it's on average very close to one another, this score, then you can say that there is an uncertainty on the relevance of the document, because it's very unlikely that the top 20 documents are all relevant to the question. So there is a first assessment on this document relevance, and then there is another assessment which will be on the question on the answer, provided by the question answering system. So that's the next step. So a perfect transition. So here, as I said, so we relied on the BERT, which is a big language model developed by Google using the transformer attention model. So I will not dive into the details of BERT. I mean, there is a very big literature about that. Even it's called the BERTology now, the analysis of how BERT is behaving for different tasks. But for question answering, how does it work? So basically, you have one document in, or actually n document, but you process one by one. You split this document in different passages, so just a chunk of these documents to try to identify which are parts of the document which are the most relevant for the current question. You pass the question in parallel also, so everything is vectorized. And for each of these passages, the QA engine is able to provide you a prediction of the relevance of this passage to the current question. So it's actually a little bit more complicated, because so if you look deep into the vector representation, so you have some token for question initialization, the separator for the passage, so this small chunk of document, and then the end of document and some padding at the end to have a fixed vector size. And so the system, the prediction is actually predicting the start and the end of the answer. So as I said, this kind of model can only pick answers that are in the document. They are not building an answer. They are not constructing an understanding of a document or doing a summary. They are just selecting part of the document, which is very likely the answer of the document. So as you can see, you can combine this prediction, because sometimes you have a low prediction for the end because the answer is actually over multiple passages. So this is why you have this prediction aggregation at the end to predict the most relevant passage, which could span over these different span here that you identified at the beginning, and to find a final answer, which is actually a list of ranked answer ordered by a score. And this is a second way to assess the quality of the answer, is to check the score and to check how the distribution is done over all the answers that are provided or selected. Quick analysis that we have done offline for this study. So we compared actually BERT that we retrained and adapted for multitask, and Dr. QA, which is a model from Facebook. So what is important is the multitask part, which was a big gain for us, which is actually just retrain the model so it can reject question where is almost sure you don't have the answer. So it allows to simultaneously reject questions, so saying I don't know, which is actually it was an important part of this application for us, and also being able to answer yes or no question. So not only selecting a span in the document, but also saying yes or no when this is this kind of closed question. So Dr. QA is not doing multitask actually. So this is why it has a very low score on squad 2. He had actually very good score on squad 1. But on squad 2, where there is a lot of questions which are supposed to be rejected, Dr. QA is not able to reject, so he has very low score, which was consistent with our dataset, the FCOM dataset. So BERT, the difference between BERT with or without the multitask is not that high because the score on squad 2 are already very high, but still these are interesting. And for us, you can see that the usage of the multitask allowed us to gain quite almost 6 points, which was quite important. So keep in mind that this score is very low because, as I said, there is question about table, there is question about graph and stuff like that, and as a specific domain, we should retrain or fine-tune the model on our domain, but our dataset was too small for that. But still, these scores were encouraging, and the first experiment that we did with the prototype allowed us to continue, and we got good feedback from the engineers.
Gérard, since I see questions coming in, guys, I know that we have consultants, novice people who might be just scared about that. Looks really technical and all stuff. We will have many more questions, don't worry. And we will also look how we can generalize the learning from that in other domains, what it really means. So we come to that at some point in the end. But
yeah. Actually, I think that's these two are the most technical slides that I have. So it's done. We passed the peak. And then, so yeah, for the conversation engine part, so the dialogue engine, we used Rasa, which is an open source startup in Berlin, which is providing quite a reliable model for intent detection, entity detection, and also the dialogue policy management. And it's quite interesting. Their tools are actually good. We compared with some others, but in the end, we selected Rasa for different reasons. And yeah, what was interesting for us is this conversation-driven development that they propose, where you have a platform and you can revise your model dynamically based on conversation experience, so real conversation that happened with your bot. So you don't have to have a full-scale bot covering all the use case that you have at start and to imagine all the cases, but you can launch it, experiment with it, play with it, and step by step complexify the dialogue model that you want to use. In the end, we package everything in this user interface. So it's just a quick view, just to understand. So on the left part, you have the chat part. So I think in green, these are the questions from the pilots, and in dark, these are the answers from the bots. Here you have the list of the documents that are selected by the search engine. It's actually a mix between the document score and the answer score. So it's providing an answer, but you have access to all other answers also. And when he's providing an answer, he's popping up the right documentation. So as I said, this looks like these are actually PDF version of the documentation. But this was very important to have almost half of the user interface coming back to the actual documentation, which is the official certified reference. So even if the chatbot can provide some answer, the pilot is responsible to double check and to double check in the reference documentation that is certified for this aircraft. So in that situation, we don't have yet to certify the answer provided by the chatbot because you still have access to the core documentation, and the pilot is still responsible as he was before when he was just using the documentation by himself. What time is it? How much time do I have left?
We have time.
Okay, I don't mind getting over the timing, but I don't want to eat too much.
Don't worry.
So the last part, which was actually the most interesting part for me, was the human experiment. So I'm a bit biased because I love human experiments in the good way, of course. But to be clear, in this kind of system, you can implement different experimentation protocol. So there is, let's say, the interactive experiment with real human and the automatic experiment with simulators. So as I said, I'm a big big advocate of interacting with real human. Well, for us, it was the only way to validate two of the hypotheses, which were related to the experience and behavior of the users. So, I mean, if you simulate the behavior of the user, you cannot really study its reaction to the system. It was also a way to have a more concrete feedback on the perception of the system, especially as a side study. We did some experiment with the voice interaction, and we had some very good early feedback about that. And also, I mean, humans are people, and it's always good to get the perception of real people on these heavily technical systems. On the difficult aspect of the experimentation with human, it's much more time consuming, and the answers to your research hypothesis could be perceived as less conclusive because, of course, humans are human, and you have this perception problem, and let's say each human reacts differently. So in the analysis of the data, it's often more difficult to have a strong conclusion. But it's actually often also highlighting some parts of the system which are not as good as you expect. I mean, I still have to highlight that you can still do a simulated user evaluation. You collect much more data because you can simulate as much user as you have compute power. The metrics are more precise, of course, because you escape the emotional aspect or the perception aspect of human. And on paper, you can do a scenario which are much easier to reproduce. But in reality, there is a lot of drawbacks, at least in my personal point of view, on this simulated user evaluation. First, how to simulate a pilot, which is actually a highly trained operator with often very strong let's say, analytical intellect in how he's executing a process in the aircraft because of his training. But more generally, how you simulate a human, that's an open question, an open research question, of course. What is really measured when you do this simulation of users? In the end, are you really measuring the performance of your system or the performance of your simulator? And is it really reproducible? Because these user simulators are often lost after the study, and it's very difficult to reproduce this kind of evaluation, even if on paper everything is encoded and you can redo it. So in the end, of course, we selected the interactive experiment. Well, because I decided it. So a few things about this human experiment. So you have to work on the protocol, and designing interactive evaluation protocol is actually not trivial problem. So you have to triple check how it's done in the literature, particular to design the search task and the search problems that you will submit to your subjects during the study. You have to define the experimentation, the experimental condition. So that's why we partner with pilot school here in Toulouse, which has access to these simulators, which was the closest that we can do for our experimentation, as close as possible to the reality of flying with this assistant. Of course, we were not allowed to fly with this assistant. That's way too dangerous, of course. And also you have to select the population on which you will work with. In our case, we had two different populations. One which was the internal pilots from Airbus, which are experienced test pilots. So there is a bunch of them. There is one advantage working with them, where first they are Airbus employee, but they are not that much accessible. They have a lot of test flight to do. But one drawback is that these pilots are actually too specialized. So they have hundreds and even thousands of hours of flights already. Often they are retired commercial aircraft pilots. And they are so much accustomed to do experiments and tests that they have their own bias. So we selected in the end not these test pilots, but student pilots, which were for us a better indication of how the future pilot will use our system. Well, first of all, because the current pilot in training might be the user of this system in the future, in 10 or 15 years. So these are the actual future users. And also we wanted to test with a pilot with a little bit less experience and maybe more, let's say, sensitivity to the use of technology. So that was, we selected these student pilots. One drawback also of human experiment is that you have to apply for ethical approval. So just to be clear, there is we collaborated with the laboratory of the ENAC school in Toulouse, which is part of University of Toulouse. So they have their own ethical committee on which we had to submit 2 times actually our experimentation protocol, because we missed some tiny things in the first submission. But at the end it was approved, and so it's just to check that data is handled correctly, that the subject of the study are currently correctly informed of what you will do, and that you are not stressing them too much during the experiment. In our case, I think it was okay. But it was actually quite stressful for some of the students. And then you have to plan, to test, to replan, to retest, a lot of back and forth in this cockpit to ensure that the prototype is behaving correctly. And we had a reference system that is also usable during this experiment. So we ran the experiment, we collected data, and at the end, we had our results. And so this was actually early this year. So we ended the cockpit simulator experiment in February. After that, so we had a bunch of data, and we came back to our research hypothesis to check how much can we validate or how much can we reject actually. And that's also an important part of research, I would say. It's that not every hypothesis that you had 2 years ago can let's say, resist after an experiment like that. And it's quite interesting to see. So our main result is that the type of search affects strongly the kind of document that the user are using, and also the performance of on the task completion. And that's actually a very strong factor, almost stronger than the system that they use. The work role and experience do not really affect the different type of documentation they use or their behavior using the documentation, which was a bit surprising. So first of all, on the experience part, we were only using student pilots, so not that much experience, but actually quite a wide range among them. Some of these students never flown yet, so they started their school, and some have already hundreds of flights hours, so quite impressive. But not up to the thousands of flight hours that a commercial pilot can have yet. And then on the last hypothesis, so part of it was quite validated with regard to the information seeking strategy and the impact of the system and the task difficulty, but not that much on the experience on the role. Not that the experience was not tested, it's just that it was not significantly impacting the performance of the subject for each of the tasks. So in the end, what we kept, let's say, from this long study is that the perception that users have in the system is actually quite good indicator of the search performance. So it's when the user have a good feeling, I would say, with the usefulness of the system, and when they feel that the system response are very relevant, these are very good predictor of the search performance. So it can be seen as obvious, but it's not always obvious when you are facing a stressful situation in a cockpit and you have other tasks to do, like maintaining flight altitude and speed, or making a rock go around because of the situation. And the last point is actually that user satisfaction with the system is absolutely not a good predictor of the search performance. So that was actually more important for us, these negative result, I would say, which is just saying that if the user are happy with the system, it doesn't mean that the system is good. So that's very important because when we will develop more and more this prototype, relying on user satisfaction and their just perception on how they're happy overall on using this system, is it a good predictor of the usefulness of the system? And actually, our study showed that it's not. So it's really more focused on the information presented and the content that relevance of the content presented, and not on the overall satisfaction. So making a system that is that has a good, let's say, that is providing a nice user interface and provide a good feeling to the user is actually not a good predictor for performance in this kind of situation. So in the end, what were the lessons learned on this study? Yeah.
Just a quick question, if you go back. Did you distinguish situations in that research? So did you say this was a situation where we expose pilots into stress to use the system, like finding a quick answer to an engine problem or something like that?
Yeah, actually, I skipped a slide, I think.
Did you not distinguish that?
I have here, you can see it. I will,
Yes.
because the presentation was much longer than that at the beginning. Sorry. I want to keep the question here. Okay. So these are the tasks that we defined for the experiment. So actually 5 tasks plus a tutorial. So tutorial was just for the user to get accustomed with the 2 different systems. So very simple, it was very simply related to some of the responsibility of the captain in the cockpit. Then 2 easy tasks and 2 hard tasks. So easy and hard was actually a multifactorial analysis that we did on the difficulty of the task because of the stress, because of the urgency, but also on the difficulty to find the answer to the question. Some of the questions that were asked were easy because you just have to find the right procedure and then you have the answer, boom. So for example, finding the flight level when you have a windshield crack, which is a crack in the window here, is actually, there is a procedure which is very simple and it's straightforward. So it was classified as an easy task. Bomb on board, which is a stressful scenario, but there is actually a very clear protocol and a very clear procedure. So if you have a bomb on board, you just type bomb and you have a straightforward the answer of the question you may ask for that. So these were the easy tasks. And the hard tasks were a mix of more stressful situation. I mean, more stressful than bomb on board, I don't know, but multi-factor of stress, and also a multi-step in the finding of the answer. So you had to find a document which will give you a piece of information, which will lead you to another document where you have the answer. So let's say a multi-hop step process to find the answer. So overall, these were quite limited in terms of range of tasks, I would say, but we selected these 4 tasks among a dozen of tasks that we developed. And we foresee to continue to explore more and more tasks, of course. But we selected them because of their range in terms of different characteristics of the task. I should go in the depths of the experimentation protocol, which I don't have in mind, and I don't have access to the document anymore. But these were selected very specifically. Does it answer your question?
Yeah, I think it's good. It's also good just to think about how we can structure it in other cases, right?
What kind of cases you have in mind?
I was just thinking of when you said typing bomb and immediately the answer popped up, for example. So I just thought, okay, so we train a system to answer questions, yeah, but also we train people to ask questions which a system can answer quickly, yes.
Yeah.
So this is the kind of vice versa principle.
Yeah.
Prepared.
Well, actually here you just have the title of the task, but the task where a sequence of situations, then question, then situation, then question. So it's a little bit more complex than that, and we explore that. The task were calibrated to be 5 minutes in length, which can be seen as short, but in 5 minutes exchanging with this kind of system, you can do a lot of things. I think we had some of the subject we had like 20 or 30 questions in these 5 minutes.
Yeah,
which is quite a lot.
Zineb had two questions which fit very much to what you have been saying as well. So one question is that the beginning of an aircraft autopilot?
That's a big question. And as I said, I spent most of my career not in the aeronautical space domain myself, so I don't know. I mean, for sure, single pilot operation are just one step in the future, but very far in the future. Having no pilots, I don't think this is a topic of research yet. I mean, in the military domain, for sure. But in commercial aircraft, I think having a pilot is something that will be necessary for a very, very, very long time just to certify the aircraft. It's probably impossible to have no pilots. But again, these are more my personal feeling. If you should ask people from Airbus. I'm not in Airbus yet.
I think nobody would expect an Airbus answer, so don't worry about that. I think there's a similar kind of question set here if you think about healthcare. So there's a similar set of questions which were like, so is that the part where actually doctors, physicians get abundant in some ways? And the idea mostly in research, which I was told and learned, was no, it's not that the purpose, and it highly depends on the evaluation of the risk involved in the situation.
Yeah.
So I would say it might be testing things, right? But I think we're just far away from being there, because no one would say who's responsible in case of failure, and a human inside of that kind of workflow process, I think, will still remain. The second thing from Zenep, I think also quite interesting here at that point, how does the system learn new questions and answers?
Oh, just to be clear, the system is not learning question and answer by heart.
Okay.
That's very important. And I mean, we would have to go in the depths of these kind of models. But these models are trained on samples of question and answer, but then can answer much more than what they have been trained on. So in our case, when we did our experimentation on the FCOM, we did a classical fair machine learning analysis where we trained on part of our dataset, like let's say 60%, and then we evaluate on the 40% that the system has never seen. So the system is not learning by heart the answer. The system is identifying how to find the answer in the passage of a document. So that's a very, very relevant question, but very important to know that this kind of system can answer much wider range of questions, and not only the one that they have seen during training.
Interesting. Since you had the score table in front of you, Anubhav was asking, how was the score calculated and the prediction ranked?
Yeah, so the EM is exact match, and F1 is the F1 score, which is the harmonic mean over precision and recall. So these are, let's say, standard academic metrics that are used in question answering system. So exact match, you can imagine how it's working. Does the answer is exact match with the truth on this question? And the F1 is actually a little bit more let's say flexible, so you can have an overlap between the answer provided and the ground truth in this system. So that's why the F1 is always a little bit more than the EM. So it's a score between 0 and 1, which is in percentage here, so between 0 and 100. But these are well-known and accepted metrics in the literature.
Thank you.
I think I have 1 or 2 slides left. Yeah, so it's just to take a step back on this kind of project. So not focusing on the cockpit or question answering, just for let's say newcomer or people trying for the first time this kind of artificial intelligence or data intensive project. Never think that this project is straightforward and that you can have a easy definition of the problem at the beginning and a clear view of the result, and especially on the timeline. For me, it's more like this, where you have this kind of loops where it's difficult to foresee in advance how much time or how much round you will go in these loops, but these are actually quite necessary. So the first loop is more about redefining your problem. So you have the industrial problem at the beginning, but then you have to transform it into a research problem, into a data problem, I would say. So it's a back and forth between collecting information in the literature, collecting data from your domain. And it's actually a very relevant task, because at the end, you know exactly what kind of problem you can target, and you know exactly what kind of data, and hopefully you have also collected already a data set to address this problem. So you don't have a solution, but you have a very clear target at the end of this loop. The second loop is, let's say, the more popular one, where you grind and you develop algorithm. The problem is fixed, the data set is fixed, you just have to optimize the metrics on this data set. So it's tuning of the algorithm, tuning of the deep learning model, or tuning of the different components into an end-to-end system. And this is, well, I would say, where most of the people are working right now. So prototyping, testing on the data sets and stuff like that. And most of the things you see on AI are results from this first loop here. But very important to understand that this loop only work if your first loop is well done. If you have misclassified your problem, or if you have wrong data set, then you can go forever in your algorithm loop. It will not work because you are not optimizing the right problem. And at the end, you have this model or this prototype. And the last loop for me is really the evaluation part, where you put your model in front of your future user and you evaluate not offline, not with a fixed data set, but with real people, and to assess how they behave in front of this system. Because on paper, this system could provide the very good answer, but the answer is too dry, or the system does not provide enough context, and the user in the end doesn't trust the system. There is only one answer. It doesn't say where it's coming from, for example. And it's very important to showcase this against human, and to validate in a correct evaluation protocol with human, to verify that the prediction of performance that you have done here is actually a real thing when you put the system in place. So very important for me in these end-to-end studies to not forget about working on your problem statement and working on your validation protocol at the end. Just working on the algorithm loop, which is the fancy part. It's nice, but it's not enough. And I think that's it. Yeah, just a few acknowledgements. So the project was funded internally by the Airbus Central Research Technology. I just want to thank two of our partners. So the ENAC School, who provided access to their aeronautical computer interaction lab, so the cockpit simulator, and also access to the student pilots. And also Dr. Yisang Liu, which is from the University of South Denmark now, but he was affiliated with the Australian National University when we worked together during this project, and who supported us for the interactive evaluation protocol design and execution of the experimentation. So huge chance to him. And if you want to do this kind of interactive information retrieval or conversational search evaluation with human, you can contact him directly. And that's it. So thanks a lot for listening. Thanks for your questions. For more information, so we have actually 4 papers published already. So the first one was the literature review. Then we have 2 other papers more focused on the experimentation with 2 different aspects. And this last one was more on the system insights. We are working on the journal paper, which is under submission, so it's not public yet. Hopefully you will have more details. Well, the journal paper is just a complete view of all what is presented in this short paper, I would say. And that's it. Thanks a lot.
Thanks, Gérard. As you can imagine, since we are talking about question and answer, there are a lot of questions still left. And which is just fine for me to observe. You can stop screen sharing for a second so we can have talks at the moment. Let's quickly walk through it. So for anyone who has been listening until now, if you don't have only technical questions or business questions, you would like to know, or what can be applied maybe to another domain or to learn more about general learnings, just ask a question. I'm going to ask that. I'm also going to invite a few people to ask their questions directly at the moment. So now coming back to the questions, I have it basically in two systems.
Oh,
so
sorry.
let's start with some questions in the beginning from Thomas Bohnstinger. What are the computational needs for your model? Is the model also redundantly running on multiple devices or computers?
So, well, you have to distinguish the training part from the running part, really. So on the training part, for sure, if you manipulate this kind of big model like BERT, and if you want to retrain or fine-tune this kind of model, you need some processing power. It's not that much. A good machine with a GPU is enough for BERT. There is bigger model than we didn't use. We had access to the cloud, so for us the processing power was not a big issue. But just to be clear, this study and this project in terms of computational need was quite small compared to other projects in the team. So I mentioned in the beginning, I contributed to a project on a satellite mission optimization. You can't imagine the size of the computing cluster for this project. It was much bigger, and then that's just for the training part where you need the power. For the running part, it was quite small. I mean, since the system was on a tablet, the front end was just a web interface, and all the system was hosted in the cloud. But the machine to run it and to make prediction live is quite modest. I think we still use the GPU because it's a little bit faster, but with a good CPU, it's fast enough for natural interaction and conversational exchange. If you add the voice, that's another layer of difficulty, and then you need a dedicated machine for the voice transcription because that's more intensive in terms of work.
Okay. Zineb, I just allowed you to speak up yourself at the moment if you like. You mentioned in the Q&A section that you're currently working or have been working with IBM Watson, and the assistant technology, which is available as API. Can you just shortly explain your experience with it?
Well, to be clear, I did not work with IBM myself. Oh, that's Zineb. Okay.
Yeah, Zineb, are you here? Can you hear me? You're on mute. Oh yeah, yep. Here we go. Hi. So now you can speak. You're no longer on mute. You have been working with IBM.
Can you hear me now?
Yeah.
Hello?
Yes, we can hear you.
Okay, so first of all, I want to thank you for this, for sharing those precious information for this talk. Well, I make my assistant on the IBM Watson platform, and I have to review my assistants because users we cannot control them, so they are asking strange questions and questions that we did not conceive before. So I have to review to make just like an analytic and to see what are the new questions that my assistant wasn't able to answer, and that I have to adjust it or to add new entities and intents. So this is why I'm upgrading my assistant. This is the strategy I'm adopting. Is it the same for you, or you are adopting another strategy?
Well,
I hope I make myself clear now.
No, it's clear. It's just there is some echo. No, it's okay. I think the problem that you have is very common, and in deployment of this kind of assistant, having unexpected dialogue state or situation in the conversation is very, very obvious. I mean, humans are very creative when they exchange with this kind of assistant. For this specific study in the cockpit, you have seen that it was very controlled, and we defined the situation in which we put the users. So it was easier for us to channel the kind of question we had. But even with that, we had some unexpected cases. But what we did is, so I focused my presentation on the QA skill, which is one of the skill which was embedded in our system, but the system had also different skills and also a quite advanced conversational model. So the conversational model that I developed was based on a data set from Microsoft, which is called MS Marco, I think. So basically, it's a troubleshooting data set where you have a human asking questions to human experts about troubleshooting problem in computer. So I did not reuse the sentences exchanged from this data set, but just the conversation flow and the different states used. And in that model, so what we had is that we had a question from the user, answer from the expert, but also rephrasing of the question, asking for a reformulation. So we had several different ways to work around question where we were not able to find the answer. So just saying, I don't know, can you rephrase? Or you're asking about, let's say, the engine failure problem. Do you mean fire engine, or do you mean this kind of thing? So you have to try to pick some words and to rechannel the conversation toward the answer that you can provide. But that's very difficult. I understood that you have many conversations already. So picking information from real conversation is probably the key for you to progress, but it's an iterative process and it's difficult.
Yeah, thank you. Thank you very much.
I think the interesting part to just having the use case from CNAP and your use cases, your use case is pretty narrow, or can be very narrow in the application field, while CNAP, it could be kind of a service agent, right? Answering many questions which come in, which is not so narrow. You have to be aware of a broader discussion, which is much more difficult in some ways.
Yeah.
So it might be helpful if you think about how to classify the problem.
Yeah, but the cockpit situation is very narrow and very controlled environment, and also we have the chance that the situation have been studied a lot. So yeah, they have already structure and procedure for that. But the troubleshooting scenario, which was developed much more for maintenance, which is not the topic of this presentation, but troubleshooting for aircraft or for satellite operation, it's much more open and much more difficult.
Yeah. So thanks, Tine, for your answer, for your questions. I invited Kunjan to join us as well. He had a question very much in the beginning about the scope for the AI. But Kunjan, would you like to ask the question itself?
Yeah, sure thing. Can you guys hear me?
Yes, perfect.
Okay, great. Stefan, thank you for organizing this, and Gérard, thank you for sharing.
Yeah, welcome.
My question is quite simple. You said early on that 70% of the responses meet the needs of the pilots who are asking the questions. So for the remaining 30%, when the AI has processed the first question, it obviously has a short list of potential candidate answers. Is it possible then for the AI to ask refining questions that then allow the user to narrow down and basically trim down the tree?
Yeah, so there is two things that we put in place here. So the first thing is that the multitask training that we did on the BERTQA model, which is not the basic BERTQA, which is the ability to reject question. That was the first step for us, ability to be clear and to know when the model is not able to answer. And then this situation where we know the system is not able to provide the answer, then we have a specific conversation model for that. So depending on the score, we say, I have no clue at all what you're talking about. So rephrase completely your question because I don't know. Or I think your question is about electrical system. Do you want documentation about the electrical system, or do you have a failure of electric system? So you want to redirect to a direction where you have some clues. So that was the first step. And then for the cases where we were not sure of the answer, so we had some answer, but passing the threshold to say that we will provide an answer, but we are not sure. What we did in these cases and what we found out is we redirect to the document. Instead of providing the answer to the question, we say, I'm not very sure of what is the flight level for this situation, but check this procedure, which is relevant for you. And this was, let's say, an easy escape for us, but it's actually also pushing the pilot to the certified documentation. And since he's responsible of taking the decision, that was an acceptable way of doing this thing.
Okay, that makes sense. Great, thank you.
Thanks, Kunjan, for the question. In the meantime, I invited Vikas as well. Vikas, can you hear us?
Yeah. Yes. Are you able to hear me?
Yeah, we can hear you clearly. I saw that you had a lot of questions on the Google system. Let's just try to answer them. Okay.
Okay. Yeah. First of all, thanks for arranging such a great talk, and thanks, Gérard, for such a great insight on the system. Yeah. My first question is related to the there might be some cases where there may be multiple answers for the same question. For example, you're given the example of all engine failure. It's based on the state of the flight. Okay, if all engine failure at the before taking off, or if it is at some particular height. So how you handle those answers, or how the system is handling those answers? So whether the system is taking some more inputs apart from the questions or queries from the system, like what is the current state of the flight or something?
Yeah, that's a very relevant question, and a question we asked ourselves during the setup of this study. So clearly the goal in the end is to have the agent to be aware of the system state of the aircraft flight mode, flight phase, and everything you can collect from the sensors in the aircraft. That's the end goal, that's for sure. Because that's a lot of information that can drive and help providing context to these situations. But for now, in our situation, we were not able to connect to the flight management system, so the FMS, and to the other systems inside for two reasons. First of all, it's a lot of integration work. You can imagine that these systems are quite complex, and collecting information from these different systems is difficult. So it saved us time not to connect to that. And also it made us independent from the flight avionics. So the avionics of the aircraft is the part where you have certified software, certified hardware, and stamped everything for security and safety. Without connection to this system, we were able to, let's say, position our system outside of this certified environment without requiring immediately to be certified. So that was a way to test the process and to test the approach without being certified. But it means that in many situations, we had some parameter on the question which were influencing the answers. For example, as you said, the flight phase, are we on the ground? Are we taking off? Are we in cruise? This kind of particular parameter, which we don't have because we are not connected to the system, were important into answering the users. So for some question, we were able to identify these entities which were important. So either the entity is present in the question. So what is my maximum speed at flight level 360 during cruise, for example? So you have all information to answer. And for some question, you are missing some of these entities, and this is the dialogue model, which is able to detect, okay, this is the question about flight level, but I don't know which flight phase I'm in. So I will ask the user, what is your flight phase? So this is not common for a cockpit, and of course, on the long term, we want the system to know it in advance. But this is a very common scenario when you have booking assistant or restaurant reservation assistant, where you want to know the type of cuisine, the type of range price you want, and all of these kind of entities and slots that are driving your answers.
Okay. Okay. Thanks for the answer. Yeah, I have a few more questions. Can I ask?
Yeah, sure. Because
okay. My second question is about the search engine. Is like looks like from a search engine is like a document or topic classifier. Is that?
Yes and no. Well, you can see it as a classifier, but why we use the search engine as not a classifier? It's because the search engine, I mean, this is a domain that has been optimized for fast retrieval and very relevant ranking of document over huge amount of documents. So search engine, when you have to filter documents, I mean, text classification is the form of the problem. Search engine can do text classification. They are very well suited for that. And coming from the domain myself, I know that for sure, having a baseline of text classifier, which is better than a classical search engine using TF-IDF or BM25, it's very hard because these search engines have been optimized for dozens of years. So that's why it was a easy solution. And also in terms of scalability, a search engine is designed to scale to thousands, millions of documents. So in our cases, we adapted our search engine just on the A320 aircraft, which is already, I think, 8,000 pages. But we also had the A350, the A330, and all the other documentation in one engine, which was very, very efficient, and we were able to make some demonstration on different aircraft. So search engine, when you have text classification, it's often a good idea.
Okay.
Just because.
Sorry.
Well, just a second, because just a question in between. There was one other question because you mentioned TF-IDF again. You said you actually choose BM25F, right?
Yeah.
Can you explain a little bit what BM25F is in comparison?
Without the slide, that would be a little bit difficult. No, I'm trying. I will cheat. I will get the slide on my side.
Just show it again.
No, well, TF-IDF and BM25 are close to one another, that's for sure. I mean, there is the term frequency and the inverse document frequency in the, I can share my screen still very quickly. It's a bit small, but you can see it. Yeah, so there is the inverse document frequency here and the term frequency here. But the term around are actually parameters that allows you to shape the score in a probabilistic framework. So that doesn't change much, but TF-IDF, it's a pure score. So for one query, you can have a TF-IDF value of 5, and for another query, you can have a TF-IDF of 1,000. So it's very difficult to compare the score against one another and against one query and one document set or another. That's one of the drawbacks of TF-IDF, even if it's very relevant for ordering and ranking documents in answer to a question. I mean, I could go a little bit, but I don't remember the parameter key 1 and B, but these parameters allows you to shape the score of the BM25 into a probability. So the sum of all the score of all the documents are equals to 1. So you can compare the score from one query to another. So you do not only compare the distribution of the score, but you can directly compare the raw value of the score. And this probabilistic framework is giving you just a better score overall. And the F is actually just a field. So BM25 is, let's say, when you do pure text search, but when you have multiple fields in your document, like for us, we had categories, we had aircraft versions, because as you can imagine, the A320, it has been flying for 40 years. So there is multiple version of this aircraft. So these are fields that are added, and that can help you filter a little bit more your document, not only of pure text, but also on field like that. And then there is a combination of the fields to have still a probabilistic score over all the fields.
Thank you. So Vika, sorry, you have more questions. I think we should answer them as well.
Yeah, my last question would be on the multilingual system. If it is this a multilingual system, or takes only the English as the input?
So no, it's pure English for two reasons. The first reason is that Airbus is only providing the aircraft documentation in English. That's the official documentation, which doesn't say that there is some local version that is certified, for example, for Russia, for China, and for other countries. There is a localized version of this documentation that is certified by the aircraft authority in these countries and in collaboration with Airbus. But we developed only the model for English because that's the reference documentation. And two things to note here. The first thing is, which is quite interesting, is that the English of this document is not standard English, and we discovered that. It's actually a specific vocabulary and a specific grammatic form used by the Airbus engineer to write this documentation to make it understandable for non-native speaker, because most of the pilots are not English native speaker, and most of them still have to work with that. But this being said, BERT, there is a multilingual BERT, and there is a different variation of BERT for different language. There is I remember Camembert for French, but there is one for German, there is one for Greek also. So you can have, if you have another language, you can have one big transformer model for each of the language, or you can have a multilingual BERT. We didn't experiment on that. For our use case, we will probably switch on the one model per language to maximize the performance for each of the language. And because in our case, we don't expect to have pilots switching language during flight. I mean, they either speak English or they speak their native language, but we don't have users which will switch languages. So multilingual model doesn't make sense in our use case, but these exist.
Okay. Okay. Is it possible to get the, so you mentioned some engineering hackathons. Is it possible to get the data set for those hackathons?
No. No, I'm really sorry about that. I had actually asked internally to be able to open this data set for the wider community, but I mean, corporate being a corporation, it's not something that we do very often. So it's not an open data set. I'm sorry about that.
Okay. Okay. Thanks.
Yes.
Okay, that's all from my side.
Thank you, Igas.
Thank you. Thanks for the questions. I had one last question from Alexis Bokrov, who just wanted to know how long was the first phase of defining the research problem? So we know data part is usually very large, but how long was your research part?
Well, first of all, collecting data is part of research. No, that's important for me to state, and that's because often collecting a data set and building a data set and building metrics for a specific data set is overlooked as not research, but I think, and I'm convinced, it's a big part of research. To be clear, I think well, the timeline was not separated, like we do data collection, we do algorithm, we do training, and then we do experiment. As I said, it was back and forth, but we started the project in 2018, first publication in 2019 about the literature review and the dataset exploration. So yeah, it was between summer 2019 and December 2019, where we really developed the algorithm, trained the model. So over, let's say, 6 months of work with some task of data collection, adapting the data set, and recollection. But I mean, data collection is not a huge process in itself, specifically for this project, because we, let's say, subsidize it to the aircraft engineers through the hackathon, but you can do crowdsourcing or something like that. We didn't do all the annotation ourselves, so it was not that much of work. But defining what you need and how you need to shape your data sets, that's much more work. And it's usually just reading and reading and reading papers.
Yes. For Frank, she actually asked, any clue about the data set, the size is something important. So did you make your mind about how much data you actually need to have a data system in the end?
Well, how much we need is much more than what we had. That's for sure, because if you think about the Squad 2 dataset, I think there is something like 30,000 questions and answers. But these are automated question and answer built over Wikipedia. So first of all, a very large data set. Some of it is crowdsourced, I think, and some of it is automated. So it's a very large data set. So we were convinced at the beginning that we would not be able to collect this kind of data set in the order of magnitude of Squad or Squad 2. So when we scale our let's say data collection process, the goal was to have almost 500. I think we ended up with a little bit less than 500, and cleaning the data set in the end, it was like 350 or something like that. I don't have the exact number in mind, but yeah, it was small, but just enough to make some evaluation. And I would say that few hundred questions to let's say assess the capability of pre-trained model on your domain, having few hundred question and answer is a minimum. I mean, less than 200 would not have been serious.
Gérard, we have been looking very much at your patience with all the questions. 2 last questions, okay?
Yeah. It's okay, it's okay.
Okay, perfect. One is just, I think it's also quite an interesting question about the risk, mitigating the risk. Let's think about a kind of emergency situation again. Did you make some kind of comparison between looking it up in the book and using the system, how fast it is? Or to ask a question actually as it was told here, how to mitigate the risk supposedly, and also is it interactive enough such the pilot reaches conclusion fast in an emergency situation?
Yeah. So this was actually a key issue raised by Airbus engineers and by the expert of the cockpit procedures and stuff like that. They don't want the pilot to lose time talking with the assistant. That's clear. So first, in the study, we compared our system with the existing system. So the existing system is called the electronic flight book. And as I said, it's just a user interface to navigate the documentation. There is a basic Boolean search capabilities and a tree to navigate in the different sections of the document. So it's actually well designed and optimized for the presentation of information. So every procedure is always presented in the same way and stuff like that. And this is the same look and feel that you have when you look at the PDF. So we compared during the study. Really, half of the users have spent their task on the old system, and half of the user on the other system. It's actually intertwined for balancing the exposition problem. Well, just classical interactive experimentation. So what we have seen is that for some tasks, the old system is very good. And we don't want to exclude that. I mean, if there is a system that is validated, certified, and that has flown for hours, we don't want to remove that. So in the end, the final system will probably be a hybrid between the existing system and some capabilities more advanced for more complex problem, where there is more thinking, more troubleshooting, more investigation to do for more complex situation, and when there is time and no urgency. Of course, but even our system for the let's say urgent situation like dual engine and fire, we were able to quickly pick the right procedure and to focus the attention of the pilot in exactly the same time as the existing system. So in the end, how it will be integrated with your system, I don't know exactly. But for sure, the evaluation of the potential lost time is a key feature, and we will only have this conversational aspect when it's relevant. And if I can add one last thing also, is that conversation has to be understood in the broader sense. I mean, conversation is back and forth of exchange of information, not always spoken information, not always written information. So the conversation could be a pop-up on the window. I mean, user interface are doing some kind of dialogue with the user. It's just that the user input are clicks and types, and the user interface is popping up different things in response to the system. So you can have this conversational framework applied to more traditional user interface. And in the end, it could be probably a mix between vocal interface, typewritten interface, and traditional interface, but all integrated into a conversational framework. For some question, the answer will be spoken. For some question, the answer will be presented to the user. For some answers, it will just light on the board.
I think that makes perfect sense to think about the best system for a specific task, not to think about the level task to win or something like that. So you're definitely a researcher. The last question, and this is more like how can we generalize what we have learned today? How to apply a similar kind of approach for medical symptoms diagnosis? So in other words, have you thought about using the same knowledge, the core knowledge you gained in the aerospace industry, maybe in other areas?
Yeah, that's a tough question. I must be very transparent. I don't know much about the medical domain. I know that there is some efforts on having assistants trying to support doctors and practitioners in this domain. I don't know exactly the level of performance that you can achieve on this very, very specific and narrow domain where you have, I don't know, to diagnose or to select medication or stuff like that. For sure, this kind of domain are very, very sensitive. So I would not rely on the pure assistant for that. But I mean, it's similar to the pilot situation in the sense that it's a very trained practitioner with a lot of experience and a lot of training, and often training that is renewed regularly. I mean, pilots are recertified every I don't know, few years. And I guess doctors also have to renew their own knowledge because medicine is changing and medication is changing. So the users are probably similar. The precision expected from the question is probably similar. The problem would be on the context, because as proposed by, I don't remember, one of the first questions about connecting to the internal of the aircraft to know the actual state of the aircraft is easy. Technically, it's possible. I mean, it's a lot of technical work, but it's possible. Knowing the state of the human that is sick in front of you, that's something that doctors are expert in, and I don't think any virtual assistant can have this information easily, because diagnosis of sickness is a mix of probing the problem and also having some feedback, some human feedback, just saying the face of the people. So it will be probably take more time. But this being said, having this assistant just as a, let's say, external memory for the doctor could be something that work. So maybe more on the medication, on the dosage and stuff that are let's say more factual based information that are difficult to remember, but probably easier for a system to query with a search engine and a question answering system. So yeah, a trade-off that is a bit similar with some specificity and big serious health consequences to take into account and the risk to take into account.
Yes, thanks, Gérard. So thanks again I think this was an awesome talk. You showed such in-depth expertise, which was just fun to listen to you. So very
again, thank you for inviting, and thank you for all the questions. I was not expecting so much question and so much relevant question.
Okay, yeah, I think so. We get some feedback, so the questions were always good. I think yes, that's why we're here for, and that's why we have it kind of meetups so that we can ask questions, and there's no level of expertise which will never be afraid of asking silly questions.
Yeah.
So thanks again for just having joined us today, and yeah, looking outside and looking at the times we have. Stay safe, please. I'm not sure what time it is on your place. It's night, it's an afternoon, whatever it is. Have a nice day, have a good night, and hope to see you again, guys. Thanks a lot, and I say goodbye.
Thank you. Bye-bye.